morning, students. I, Omon Saxena, going to take Mathematics Class 9, Chapter 1. And the topic is expansion. Now, the expansion is a process in which we remove the brackets. Now, there are certain formula for that. Suppose a plus b whole square is there. So we can write it like that, a plus b. When we multiply these two, that becomes a square plus ba plus ab plus b square, and it makes a square plus 2ab plus b square. So this is the formula for that. Similarly, if we take a minus b whole square, that is a minus b multiplied by a minus b again. So when we multiply it, we will get a square minus 2ab plus b square. So these are the expansion of these a plus b whole square and a minus b whole square. Now, similarly, if we add these two, means suppose a plus b whole square plus a minus b whole square. So when we add these two quantities, so then these two plus 2ab and minus 2ab will be cancelled. So here we will get 2 times of a square plus b square. Similarly, if we expand or find the whole square of the quantity a plus 1 upon a whole square, so it will be a square plus 2 times of a into 1 upon a plus 1 upon a whole square. So that makes a square plus 2 plus 1 upon a square, or you can write it a square plus 1 upon a square plus 2. So this is the expansion of a plus 1 upon a whole square. Similarly, a minus 1 upon a whole square is written as a square plus 1 upon a square minus 2. Now, if we again add these two, that a plus 1 upon a whole square plus a minus 1 upon a whole square, that will become, means when we add these two, so these two will be cancelled. So this will be 2 times of a square plus 1 upon a square. Similarly, when we subtract these two quantities, 1 upon a whole square minus a minus 1 upon a whole square, so it will become, when we subtract, so we'll get here we'll get 4 by subtracting these two. Now, identity. Identity means the equation which is true for every integer. So whatever the value we put over here, when we substitute the values of a and b, so the left hand side and right hand side both should be equal. That makes the identity. So here there are certain identities given over here, and we are going to prove whether it is correct or not. Suppose the value of a is given as a 5 and the value of b is given as a 3, and we have to prove whether a plus b whole square is equal to a square plus 2ab plus b square. So here what we will do, first we will take left hand side. For the left hand side we will take a plus b whole square. Then we put the values that a is a 5 and b is 3 whole square. That makes 8 whole square, and that is 64. Now again we will take right hand side, and that is a square plus 2ab plus b square. And that a is your 5 square plus 2 times of 5 into 3 plus 3 square. So that makes 25 plus 30 plus 9, and again it makes 64. So here we can say that since the left hand side is equal to right hand side, so it is the given inequality is given identity is the correct one. Similarly, if the other values are given, we can again prove for that, for the given examples. Any values, it may be positive or negative, we can put in the left hand side and then right hand side, and then we calculate. If both sides are correct, then the identity is okay. Now, we see the expansion of a plus b whole cube. Now see how we'll get that. The value can be calculated like that, a plus b whole square, then a plus b. If you open it, that is a square plus 2ab plus b square, and then multiply it by a plus b. So we'll get over here a cube plus b cube plus 3ab a plus b. This will get over here. When we multiply, we will get the same thing. Now here a cube plus b cube plus 3a square b plus 3ab square when we open the bracket. So this is the expansion of a plus b whole cube. Similarly, a minus b whole cube is written as, that is a square minus 2ab plus b square, and this is a minus b. So when we multiply it, we'll get a cube minus 2a square b plus ab square minus a square b plus 2ab square minus b cube. So what we get over here, now here a cube minus b cube, this makes minus 3a square b and plus 3ab square. So here if we take minus 3ab common, so we'll get a minus b over here. So when we multiply it, we'll get this result. So you can see that this is a minus b whole cube, and this is for the a plus b whole cube. That is a cube plus b cube plus 3ab within bracket a plus b, all the terms are positive. Now here you can see that is a cube minus b cube minus 3ab minus a minus b. Okay. Now the next one is that the other form which we can write for this, that is given by, suppose in the place of a plus b, if we replace b as a 1 upon a, that is a plus 1 upon a whole cube. Then since we know that a plus b whole cube is given as a cube plus b cube plus 3ab a plus b. So in the same way, in the place of b we put 1 upon a, so it will be a cube plus 1 upon a cube plus 3 a into 1 upon a plus 1 upon a. So it will become a cube plus 1 upon a cube plus 3 within bracket a plus 1 upon a. Similarly, if we write a minus 1 upon a whole cube, it becomes a cube minus 1 upon a cube minus 3 a minus 1 upon a. All the terms are negative. Here all the terms are positive. Okay. So these are the formula for that. Now apart from this, let's see some expansion of, suppose it is given as a x plus a or x plus b. Then it is a simple multiplication. When we multiply x and x, that makes x square plus a and x, that is ax plus bx plus ab. So it will become x square plus a plus b x plus ab. Similarly, if we take x plus a or x minus b, in that case the term says x square, that is plus ax minus bx minus ab. So it will become x square plus a minus b x minus ab. So you need not to learn the formula every time, you just multiply it, you get the answer. Whenever the form is given in the form of formula, suppose whole square or a whole cube, only then you can write the formula, otherwise you can do by your own. So here if both the terms are negative, accordingly you can multiply that. Now after that, suppose the expansion of 3 terms are given. Means suppose it is given as a plus b plus c. This is a plus b plus c whole square. Suppose we have to expand it like that. So the formula for that is a square plus b square plus c square plus 2 times of ab plus bc plus ca. This is the formula for that. Now, so if any term is negative, suppose a plus b minus c is there, and we have to write the expansion of this. In that case, in the place of c over here, we just write down the minus c. So what it becomes, that is a square plus b square plus minus c square, that is always like that, plus 2 times of This will AB plus B into minus C plus minus C into A. Now when you open it, you will get A square plus B square plus C square plus 2 times of AB minus BC minus CA. So simply, if you remember only this formula, then whether it is minus B minus C minus A or A minus B minus C, whatever be that, you put the values according to the sign over there, you will get the result. So we can have A minus B plus C or A minus B minus C similarly by substituting the values over here. Okay. Now if the product we have to find more than 2, suppose we have to multiply, suppose x plus A, x plus B, x plus C. These 3 terms we have to multiply. Then what we'll do, we first multiply these 2. So that will be x square plus A plus B x plus AB and then x plus C. Now we multiply this term by this. So what we'll get? That will be x square x plus C, then A plus B x multiplied by x plus C, then plus AB multiplied by x plus C. So what you'll get, that is x cube plus x square C plus AX plus BX, and this is multiplied by x plus C plus ABX and ABC. So here we'll get x cube plus x square C plus, when we multiply AX square plus BX square plus ACX plus BCX plus ABX plus ABC. So see here what you'll get the one term of cube, then take x square common. So when you take x square common, you'll get A, B and C. So that is A plus B plus C you'll get over here. Now then you'll take x common. So when you'll take x common, you'll get AB plus BC plus CA and then ABC. So this is the expansion of x plus A, x plus B, x plus C. Now suppose if you remember this, since the 3 terms are multiplied, means x is multiplied 3 times. So the maximum power of x you'll get x cube, then decrease in the order, then x square, then x, then no term of x. So x cube is, because there is a multiple of x is 1 in every term, so the x cube and then x square multiplied by A plus B plus C, then x is multiplied AB plus BC plus CA, then ABC. So if suppose x minus A is given over here, so here you put, in the place of A you put minus A everywhere. Similarly rest of the term you can do like that. Now this is one more formula for cube, that is suppose A cube plus B cube is given. So the formula is A plus B and A square minus AB plus B square. So this can be written like that. Similarly A cube minus B cube is written as A minus B and A square plus AB plus B square. So when you open the bracket you will get the same result over here. Similarly one more formula is very important, A plus B plus C multiplied by A square plus B square plus C square minus AB minus BC minus CA, then the result will be A cube plus B cube plus C cube minus 3ABC. So this is the result. So you can use this formula whenever it is required. Now I'll discuss some questions based on these. Suppose the question is given, this is the question number, suppose one will take from this exercise, we have to find the square of suppose 2a plus b. So 2a plus b whole square we have to find. So we'll put it like that, 2a whole square, that is a square, plus, since we know the formula a plus b whole square, it is better you write down the formula first. That will be a square plus 2ab plus b square. So in the place of a, here you have to put 2a. So 2a square plus 2 times of 2a into b plus b square. So it will make 4a square plus 4ab plus b square. This is the answer. Now if we take suppose this question, fourth one, that is given as 3a upon 2b minus 2b upon 3a, that is 2b upon 3a and whole square. So again, this whole term is a, this whole term is b. So 3a upon 2b whole square minus 2 times of 3a upon 2b into 2b upon 3a plus 2b upon 3a whole square. So this will come. So when we simplify it, that is a 9 upon 4 a square upon b square minus, you can see this and this will be cancelled, this and this will be cancelled, only 2 will be here, plus 4b square upon 9a square. Now this is the final result. You can get the answer like that if the question is that. Now see, suppose it is given using identities to evaluate this. So now if it is given 101 whole square, you have to evaluate using identity. So what you will do, 101 whole square can be written as 1 plus or 100 plus 1 whole square. So now you will use the formula, that is 100 whole square plus 2 times of 100 into 1 plus 1 whole square. So here you will get 10,000 plus 200 plus 1. So that makes 10201. This is your answer. So in this way we can calculate any value. Suppose 97 is there. So 97 can be taken as 100 minus 3 and you can expand it. Now see some more questions. Now just see the 10th question. And the question is a plus 1 upon a is equal to 6 given over here. And we have to find the value of a minus 1 upon a. So a plus 1 upon a whole square is equal to a square plus 1 upon a square plus 2. So here we will get 36 is equal to a square plus 1 upon a square plus 2. So that is a square plus 1 upon a square is equal to 34. Now a minus 1 upon a whole square will be a square plus 1 upon a square minus 2. That makes 34 minus 2, that is 32. So it will become a minus 1 upon a is equal to under root 32. Let us check it over here. This is 6 given over here, 6, 36, a square plus square, this minus 2, 34, 34 minus 2. Okay. So this is the value for that. Okay. Now similarly you can solve other questions also. So now thank you and have a nice day.